here we're going to look at some log properties, and specifically we are going to look at how to expand a logarithmic function out using those properties. Okay, so our log properties that we have are going to be product, quotient, and power, and then of course we have some of these others. So we're going to use these ideas here in order to expand out. So for example, I have the log base 5 of 125 x to the third. So the first thing we have to do is decide what it is that we are doing here. And so if we look inside this parentheses right here is going to follow the product rule. So the way I like to think about expanding is I like to think about it in terms of peeling an onion, where in this case we have to work from the inside out. And so here we're going to work from that basically we're going to work from the outermost property into the innermost property. And so here the product rule comes first, which says we're going to expand this out to be log base 5 of 125 plus the log base 5 of x cubed. The last thing that we have to do is we are going to follow the power rule. So the power rule says that we have log base 5 of 125 plus 3 log base 5 of x. And then finally, when we look at this front part, notice all of it is numbers, none of it is variables. So here we actually have to do the math and evaluate. And so in this case, if we look at it, we would have that 5 to the x is equal to 125. And so here, what 5 to the what gives me that? Well, x has to be cubed. So my overall result here would be 3 plus 3 log base 5 of x. And this would be the full expanded version. Okay, let's look at it again. Now in this next one of the things that you need to see is that before I even think about properties, I have to factor a greatest common factor. And so here what's going to happen is I'm going to have log base 3, and then this is going to be of 9 times x plus 3y. Once we do that, now you can clearly see that this right here is going to be the product rule. And so the product rule says that this becomes the log base 3 of 9 plus the log base 3 of x plus 3y. Now the last thing I have to do again is I have my pure numbers here, so I have to do the math. And so in this case we are looking at 3 to the x equals 9. Well, we know that 3 squared gives you 9, so overall we would have 2 plus the log base 3 of x plus 3y. Now, some of you may look at this and say, hold up, wait a second, what about x plus 3y inside? Well, because these are variables and they're separate variables, this is actually as far down or as simplified as we can get. There's nothing else we can do. And so log base 3 of this hunk of junk of stuff is as far as we can go. Alright, let's look at this next one. So here, this next one, we've got a lot of weird, crazy things going on here. Okay, so first and foremost, we have to work again from the inside out. So if we look specifically, we have right here a product rule. So here we have this log on the outside that's going to remain on the outside for now. And then on the inside, I'm going to have the log of 100 plus the log of x cubed. Now with that, here we have a power rule. And not only that, right here I have some math that I can do. So here I have to do the math because this is just pure numbers. Now the other thing to keep in mind is that I don't have any base written, therefore it's a common log. So here I would have 10 to the x is going to give me 100. So in this case we know that that's going to be 2. And then I have my power rule. So this becomes the log of 2 plus 3 log of x. And in this instance, now there's nothing else to do. Because I have this plus here in the middle and there's nothing I can pull out, there's no greatest common factor, this is actually going to be the expanded value, meaning I can't expand any further. Alright, let's look at one last one that's really going to kind of kick things up into a new level. So here I've got a bunch of log rules that we have to be able to unpack. So again, we have to look at the outermost rule first and kind of work our way in. So here the outermost rule that I have is going to come from this 4. So we need to rewrite into an exponential. And so here what's going to end up happening is that this is really the same as log base A of m to the 8th n to the 12th all over a cubed b to the 5th to the 1/4 power. Now with that, this is going to follow the power rule. So the power rule says it's going to come all the way down out in front. And so here, this is going to become 1/4. And then I have the log of my stuff. So m to the 8th, n to the 12th, all over a cubed, b to the 5th. Now the next outermost rule that we're going to use here is going to come from my fractions. So this is going to be the quotient rule. The quotient rule says that you have to subtract. And so in this case, what's going to happen here is we are going to have my 1/4, and it's going to be the log of my numerator, so m to the 8th, n to the 12th, minus my denominator, the log of a cubed, b to the 5th. Now, in looking at this, we have more rules we can use. So in this case, and in this case, I have the product rule, which can be applied in both situations. Now, the other thing that I have to keep in mind is the fact that I've got this negative here that now can't be forgotten. So when I go to rewrite this, again, I'm still going to have the 1/4 on the outside, and I'm still going to open a giant bracket. But now what's going to happen here is I'm going to have the log of m to the 8th plus the log of n to the 12th. And this is going to be minus, and I need to open a parentheses because my product rule says that I'm going to have the log of a cubed plus the log of b to the 5th. Now the next thing that has to happen is that my negative here has to be applied into both. Okay? And so before we even look at the next rule, I want to apply my negative through. So here we're going to have the log of m to the 8th plus the log of n to the 12th minus the log of a cubed minus the log of b to the 5th. Okay, now let's keep going. I have all of these powers. So these are going to follow that power rule again that we used in the very beginning. So my power rule is going to apply to each individual log. So this is still going to have the 1/4 on the outside, but now I'm going to have 8 log of m plus 12 log of n minus 3 log of a minus 5 log of b. The very last thing that we need to do here is we need to take this number on the outside and we need to distribute into my logs. And so here what's going to happen is the 1/4 is going to distribute over. So this is now going to be 8/4 the log of m plus 12/4 log of n minus 3/4 log of a minus 5/4 log of b. Now, I'm going to change colors here. This one I need to reduce, and this fraction I need to reduce. So the overall result is going to be 2 log of m plus 3 log of n minus the 3/4 log of a minus the 5/4 log of b. And that would be the totally and final expanded form of the log function. So again, one of the things that you need to do is you need to take it one tiny step at a time, expand piece by piece, start with the outermost function or the outermost property and work your way in. So if you have any questions on expanding logarithmic functions, please let me know. Otherwise, I hope you enjoyed this video as much as I did, and I'll see you next time.